So in today's video we're going to look at this Time Electronics Programmable Resistance 9811. This is a precision decade resistance box. Like high precision. Like good. So apparently these things have been made obsolete over 10 years ago, so it's quite an old unit really. Which suits me, I like old stuff. I did some testing on it really, I showed you the mailbag, I just went through the decades and looked at some things on there and just have a look at see what was going on. And there were some problems identified. So I'm going to demonstrate that again now, in case you didn't see the mailbag video. And I'll just show you what I found, and we'll try and fix the problems I found. So I'll start by turning it on. So this key switch here is actually the power switch. So local mode means we're using these dials here. Let's put this to resistance. Just to leave resistance is 0.3 ohms. Now what this actually has on the back is, actually I'll show you. It's a mess of loops right now, but it's got 3 individual pairs. This is 100 ohm, 10k and 1 meg. That's the 3 banks of individual cards which has got the relays and resistors built into them. And it's got a GPIB and stuff like that on it, which is why it's programmable and has remote access. So I've got these loops in here which obviously going to be adding to it a little bit, but it's a marginal error. Okay, you can see 0.3 ohms with all those leads because I've got them daisy chained from one to the next. It actually gives you a readout here of what the current resistance setting is, because if you're on a remote then it will be remote controlled, and obviously this is then not used. But on local control then it will use whatever you've got set here. See, that's how that works. And if we go to remote, it can be something else. That's why it's got the display there. Otherwise you'll be thinking, must be pointless. Well, actually that's why. So basically I've gone through the decades on this thing, and so I've got a 800, which is one of the ones I found, and that's actually reading slightly high. Okay, and 100 ohms, 200 ohms, 300, 400. See, these are all absolutely fine. So you get 800, it's slightly high. 900 is also slightly high, and I'll explain why shortly. The individual ohms are fine. Okay, the decades on that, no issues there at all. K's, 1k, slightly high there, 2k, 3k, right, all very slightly high by just a little bit, but that could be nothing really. Right, I didn't really find much wrong there in reality. It's basically right. 10k, 30's reading fraction high obviously. But I actually checked these on my Siglent multimeter, my 6.5 digit, because obviously this doesn't show everything. Right, it's somewhat limited. Let's go through here. So you can see 100.1k popping up here. Okay, so you've got 200.2, that's slightly high as well. 300, because that's 1 and 2 together, I'll explain that shortly. 400 is even worse, look at that, that's 1.1 out. Those out. Set next range up. That's 1 up as well there. 800 is 4 up. 900 is 4 up. You can see we've got some error on here. Now I've actually verified this on 3 different multimeters. It's not just an accuracy thing on the rounding or the digit display on this particular multimeter. I've tested on 3 different multimeters, including my 6.5 digit, and it all gave basically identical results. There's something wrong with these ranges. We need to pull this card out and I'll explain what's going on. So I've got the whiteboard out. About the time I started using this thing. I've only used it a couple of times so far. This is kind of a circuit example of what I've found. So 800 ohms, which I demonstrated was slightly high. It's about 600 milliohms high. I think it's about 0.075%, which is above what I think it should be. It's got 0.05% resistors in most of it. It does have some 0.1s as well, but most of it's 0.05%. So it should be very close to the actual values. The 100k range, I've got that one in green because that actually looks within spec, right? It's just slightly high, but it's still okay. So I've got that one in green to show that's looking alright. But the 200k, 400k, 800k are all wrong. And as you saw, the 800k, that's specifically very wrong. Now how these work in these decades is they're actually like a bit of like a BCD type system. You think about BCD, which is 1, 2, 4, 8 is used for the actual coding. And this is the same as this, 1, 2, 4 and 8. It's got 2 sets of resistors on each card. So it's basically got this twice on each card. So that's why I've got the ×2 here to demonstrate that there's actually 2 of these in series together. So in the case of the first unit here, it's like those 2 there on one card, those 2 there on one card, those 2 there on one card. And it does 1, 2, 4 and 8 as I said, and it's got normally closed relays which are in place across each resistor. So when it actually wants the number 1, it will open that relay up and that will then pass through that resistor. If it wants 3, it will open up 1 and 2 to give you 3. And if it wants 4, it'll open up that one instead. If it wants 7, it'll open up the first 3, and that's how it works. Which is why when we're seeing the 100, 200, 300, 400, 500, 600, 700, 800 and 900k, they're all out. Because 1 or 2 of them could be wrong. So the 100 is very slightly out, as you saw. It was just rounding up a little bit and being slightly over. Not much, but just enough to trigger it. But when you combine that with a 200, to get the 300k range, the error is increasing because that becomes from 500 ohms high to be 530 ohms high instead. And 400 is obviously at 1.1k. If you do it 500, then you got 1.1k plus that 30 ohms. So it's 1.13k high. And the same for 600, which would be those two added together. 700 is all 3 of those. 800 is this one. 900 is this one plus that one. Okay, so as you add them all together, obviously you're going to get greater errors. If they're up and down a little bit, then you actually might find the average out to be more accurate. But in this case, these are all reading high. I think something's going on with this particular card and there's a problem. So I think I actually need to work on this particular card and figure out what's going on, because all of these resistors are slightly wrong. There's also 10, 20, 40 and 80 on that bank as well, on that same card. They seem okay. I couldn't really find anything wrong with them. They look like they're alright. So it just seems to be this set of resistors, which is interesting. So these two circles at the end here, these are the 2 connections points on the back. There's banana jacks on the back. And that's why each card is basically separate from each other, which is why I've got them all daisy chained. Otherwise you just use one pair, which can be beneficial if only using relay measurements. You can reduce some of your error. In this case I wanted to cover the whole spectrum of what this thing can produce, so that's why I daisy chained them all. Let's take all those out, because we're not using those now. We want to take this section here out and have a close look at this and try and figure out what's going on with it. So it's got 2 screws to hold this thing in, and it literally is a plug-in card. So if you watch the mailbag video when I received this, you'll see exactly what I'm doing now. Basically, I pulled the cards out and actually had a look at it before I powered it up for the first time, because this thing had been inspected by customs for some reason. I decided I wanted to inspect it, so I don't know if they're the ones that opened this up, because all these seals are broken when I got it. So I'm guessing it's because they opened it up. I don't know. Anyway, here is the card we want to look at. It's a nice precision goodness on that card. So that's what it really looks like. And here's all the wiring for it. It looks like it just goes in the sequence from here down to here. Don't think it crosses over. No, it doesn't. So it's the same sequence here to here. In case you ever have a wire pop off, maybe, if you've got one of these things. Hope you can see the pins and stuff there as well to see where it's actually placed. Bit of an interesting setup. So up here are the smaller value resistors. So there's 10k, there's 20k because we've got 2 10k's in series. There's a 40k and an 80k here. And down here is the 100, 200, 400 and 800k resistor. So these ones here are 0.01% up here, right? So these are really good. And these ones are 0.05%. This one's a 0.1. So the 100k is a 0.1. So that's why that one being slightly out, even though it looks fine though, right? So it's actually really good. But these other ones are all 0.05%. So I should be expecting better accuracy than what I'm getting. They shouldn't be as far out as they are. The interesting thing is let's see some flux residue. I can see some flux around these holes. Like maybe someone's worked on this in the past, which is interesting. Also got this other resistor down here for some reason, which is also curious. Looks like it's a bit of a trimming resistor going on, because that is in series with this one. So the 200k has got this one in series with it, which is interesting. I wonder what value that is. Because you look at the back of the board here, the way they've got this arranged is that you can actually tweak these values by putting either series or parallel resistors in there with the precision one. So if it is slightly off value, out of spec, you could tweak the values, which is exactly what they've done here by putting a series resistor here. So this one here is going from this side to there, and it comes back over here and into there. So that's the link between the 2 resistors just there. I have to read that value off there. So that's that resistor there. So I can't determine yet which way around these bands go. So it's red, purple, yellow, black, brown, or brown, black, yellow, purple, red. Did I say that right? Because one of these is probably temperature coefficient, or could be accuracy, I'm not quite sure. But yeah, it's also going to be a precision resistor. I just don't know what these bands are yet. I'm going to sit down and figure this out. So after looking at these colour bands, trying to sort of determine which way around it goes, I believe it's a 274 ohms, 1% resistor. So it comes from this end. So it's 274, black is times 1, so it's 274 ohms, and brown is 1%. That's what makes sense. And to verify that, I hooked up my Fluke multimeter here, measured across that resistor, and I can actually measure this one in this case because of this value here being so big. I was able to measure it, and it is indeed 274 ohms. So that is correct. So we're actually up by 500 ohms, so that trimming resistor probably shouldn't need to be there. It's a bit strange. So the problem with this is that I would just like to just measure the resistors. If I just measure the resistors directly, I'll know whether it's the relay or the resistor. The problem is, because these relays are constantly closed, they're normally closed state, I can't measure the resistors because they're shorted out by the relays. Bit inconvenient. So I set a bit of a look online for these relays, these NACE S2 series relays, and I found a data sheet for them of RS components. So I know what the pinout is. It actually has a bottom side view in the diagrams. So it's 1, 2, 3, 4, 5, 6. And these two here, the coil, which is pretty obvious anyway by following the traces down. You can see they've got paralleled up connections, and it'll come down to the chip down here, which has got these legs going to it to control it. That chip there. So that's all the control circuitry on the coils. Then we've got it's a double pole, double throw relay, but it's got individual poles. They're actually not like shared, common. It's got individual ones. So these two here are normally closed, those two there normally closed, those two there normally open, those two there normally open, and these two end pins here aren't actually connected to anything, they're not used. It's actually only got 4 pins which are actually being used on the actual relay contacts. And I can get these relays. They're $40 each to buy brand new. So if there is a bad relay or 3, I could easily replace them, which is good news. It's actually unusual to find relays I can actually replace because they're usually obsolete, but these ones I can still get, so I'm going to be buying some, even if they're not bad right now. I'm thinking it's the resistors have gone off tolerance, maybe they've been stressed or something. So what I'm actually going to do, although I don't really want to do it, I'm kind of forced to really, is desolder. Maybe I can just desolder one joint, and so it's reduced the stress when I'm doing the desoldering. I don't want to heat these things up really. Maybe this one here, measure that and see if I can see what's going on. But no, the 800 is definitely bad, so I probably want to target this one actually. That junction here between the 400 and 800, that's like some of the worst ones, is that pair. So if I desolder that, lift them out and measure them and see what we get out of circuit. So I'm going to start with just by putting some fresh solder on, just to give me a chance to actually desolder this a little bit more easily. There's a big thermal mass here, there's a massive pad. Actually I need some more heat. As much as I don't want to put heat into this, I really want to avoid it if I can. But it's a big thermal mass here. Got to try and warm all this up as well with the iron. Get this melting with fresh solder, so it makes it a bit easier. Bit of fresh flux and that sort of stuff. Just makes the job a bit easier. I think they might be folded over. There's definitely something between them. Let's wick this off so we can see what we're dealing with. And then I'll use a desoldering gun after that. There's so much thermal mass here. This is the biggest tip I've got right now because the tip I was using for doing big stuff failed. I haven't replaced it yet, so this is the biggest tip I've got right now. Right, what we got here? I might have to use a screwdriver on this, I'm not happy about it, but yeah, they're bent over together towards each other. So let's just try and level them up. Then I can use a desoldering gun and get the things out. I don't like putting all this heat into it though. I'm really not liking that. But right now it seems to be the only option I've got. Okay, there we go. Right, now I can get the desoldering gun onto it. Yeah, it's kind of done. Yep, that's off. That's off. Great, they'll lift out now. Obviously now I've heated them up, so they're going to be of value. Anyway, here we go. That's lifting out, and that's lifting out. Let's try and get them all the way out. Right, let's measure these things. They're still slightly warm. So we've got 401k, which was high, and 804k. Right, that tallies what we're seeing. So yes, the problems are the resistors. But that's kind of annoying. So while I'm doing this technique, I might as well just lift this one up and measure the 200k resistor as well, which is the other one which I was a bit worried about. By taking this one out, it means it's no longer shorted by the relay, so I should be able to measure it. I've taken out the less critical resistor. 199.8, haha. Okay, and this is 274. So yes, it was down by a little bit. Okay, A 274 is going to be taking it closer, but I think it's probably a little bit too much actually. What if I can something to do about that? So, based on this percentage here, 0.05%, at worst case it should be 800.04, according to my maths anyway, unless I'm doing it wrong. So that is 2 orders of magnitude out from where it should be. So I think I need to look at these resistors. Maybe they've been damaged, maybe someone's put too much power through them or something like that and actually damaged them that way. Which is maybe it's why it's only on this range, because it's been flicking through on that high resistance range and it's damaged these. That 200 is reading slightly low, but this one's overcompensating very slightly. Maybe it's the closest value, I don't know. I probably do have better values, but whether we've got the same accuracy and the same temperature coefficients, that's a different matter. I imagine this has got a much better temperature coefficient than anything else I've got sitting around here. But I probably need to look at replacing these resistors, because there's not a lot I can do about reducing them unless I pad them with a parallel resistor and potentially live with a bit of error or instability across temperature. So I've been doing some searching online, so I can find the relays, that's not a problem. Trying to get these resistors seems to be a bit more tricky. Trying to get something equivalent to what's in here seems troublesome. I'll keep looking, I'm bound to find something I can actually replace these with, but these two do need replacing. So this one here is a 274 ohm, as we discovered. This is 150 ohm. And this one here is reading above value. So it's actually reading 199.86k. At 274 ohm is too much for it, but the 150 ohm is going to be much closer. That's a much closer value, so I'm going to go with that. I'm going to see how it goes. It's a 1 watt resistor, so it should be able to handle the power and that sort of stuff. It's actually bigger than the one that's originally in it. 1% resistor as well. Temperature coefficient, I don't know. It's probably not great, but it's probably not that critical. As soon as it's only at such a low value, so 150 ohm against a 200k, it's going to have very little influence on that. Even if the temperature coefficient is pretty bad, it's not going to be so bad on the actual reading. It's still going to be probably more accurate than what's already there. It is strange that it's so far out, but I think someone stressed it, and that's what they've done, is they've gone flicking through the decades and blown these resistors or stressed them and damaged them. I think that's what's happened. So ideally I'll replace all 3, but I think for the time being what I've done for the 200k at least will work, which means the 100, 200, 300 will work at least and be better. The 400 through to 900 obviously still have problems until I replace these resistors. I'll have to find some. I mean, there's a 0.05%. I imagine the temperature coefficients on these is pretty low as well. Obviously that's going to be something I'll try and find is the best I can. Even if I have to spend $20 per resistor or something, I'll do it, just to retain the quality of these. If I spend $60 replacing these resistors, yeah, no big deal. I'll do it. Yeah, it's a bit annoying. Anyway, it is what it is. So we'll try it out with what I've done now. We'll see how close it is now. Right, let's test this thing out. So we've got 0.3 ohms there. I've still got it connected up in series. I've got the little daisy chain going on the back there, so I'm getting the full range. I could have just hooked up just to that set and just measured that set only, but I like to keep the conditions exactly the same as it was in the previous test. 0 ohms, 100k. Getting exactly 100k, so that's good. I'll check this on my 6.5 digit as well in a minute. Oh, just flicking the 1 there. But I didn't change the 100k resistance. That's exactly the same. I've done nothing with that one. 200 is one I modified, and that's showing exactly 200. Previously it's showing 200.5, so that's an improvement. 300k, because that's the 100 and 200 combined. That's looking pretty much perfect. 400 is one which is faulty, so that's 1.1k up. I need to fix that. Obviously I need to replace that resistor. 500 should be the same, yep. 600 will be the same, 1.1 up, yep. 700 will be 1.1 up as well, but you can only see the digits there. 800 is the one which is also needs to be replaced, and that will still be the same as well. So yeah, I'll chuck this on my 6.5 digit as well now and just have a look at that one. So here we are on the Siglent 6.5 digit multimeter, so it's a bit more resolution than the Fluke. So still 100k. There you go. Once it's settled down, we're at 100.03. So it's at 30 odd ohms I was seeing as being slightly positive. So that's okay. I mean, I haven't got any zeroing on this thing yet. I mean, I could manual range to let's do 200k range, and we see the rounding on that. That's basically what we're getting. If I do 100k on there, yeah, so you can see the error there, right? So it's basically 30 ohms. Also got a little bit of noise going on here. I've got 10 power line cycles. I could increase it, but it doesn't really help that much, to be honest. because it's still excess. If I did like half a power line cycle, we can see how much noise there is there. 1 power line cycle. See, it just makes it quicker to respond. 200k, which is one we tested and played around with. Oh, look at that, that's much better. It's bouncing around each side of 200k, so that's looking really promising actually. Don't forget this is 2-wire measurement, not 4-wire. I could do 4-wire kind of, at least to the terminals on the rear panel, which would help very slightly, but that's looking much better than it was. Previously it's half a K up from that, so it's much better. That's a much better result. And the 300. There we go. That's looking really good too. Let's do 400. And there's the error there. Like you've seen before, 1.1k up. If I go to 800, here we go. Give it one more cycle, there we go. So basically it's 804k. So it basically is 4k high. Alright, so yeah, it's I need to replace those resistors. That's a real shame, but I'm going to have to do it.
One eternity later.
So these are the resistors I've got to replace the 200, 400 and 800k resistors. So I've got 400k resistors here, these are 0.1%. Metal film, 1 watt. So the temp code and stuff's okay. It probably doesn't really compare to the originals. The originals are probably better, but as you know, they're completely off value, so it's completely pointless worrying about that. I'm just going to sit down and choose the best values I can at this set. This is what I've got 40, so I can sit down and select the ones which suit. So being 400k means I can just put a 400k straight in that place. For the 200 I can put 2 in parallel to get 200k, and the 800 I can put 2 in series to get 800k. And the board allows for those configurations, so that's not a problem. I can do that and get them really good. So what I'm going to do is sit down my Siglent multimeter here and do some selections with these. I probably won't bore you with that process on the camera. I'm doing it for the live stream because I've got people watching, but you know, I can do it on stream a bit easier. So I'm just going to sit down and select the best value resistors, and then I can replace the ones that are inside this unit.
A few moments later.
We've done testing. We've got a 400k. We have 2 400s here, which are obviously going to make the 200. These are a good balance. And these 2 here are set up as the 800. So we've got the resistors we need to replace these 3 which are giving us trouble. I'm not quite sure what I'm going to do with these original resistors. I don't want to dispose them. I kind of want to keep them with the gear. Doesn't seem right to separate them from it. So I'm not quite sure what to do with those yet. I don't know. Anyway, don't mix the resistors up. Alright. So we've got this one here. Make sure I'm doing the right side. Yes, I am doing the right side. So this one here. The other thing as well is also soldering the resistors in might change them. I don't know, maybe it will. So I'll try and minimise heat when I'm soldering new ones in if I can. I'll take this resistor here off because that's one I bodged in to try and correct that 200k value, which was off. So when I put the other one in, I've got to go straight from here to here instead. Oh, let's desolder these things. Okay, that gives us a start. A bit messing around still. George, get off my chair. No, too late, she's on. And there's no point telling you anyway, she's deaf. And for those of you watching a recorded video, I'm talking about a cat. Clean this up. It's only a single-sided ball, but there's some residue on this side just come through, so I just want to get that off. Really put the resistors in. So I put the 400 in, it's putting in the ones for the 200, which would be in parallel with each other. I do like the way they've done the circuit design. This thing, so it actually just gives you different configurations depending on which resistors you've got and for tuning and stuff like that. You put a lot of thought into that design, it's quite good. It means you can put them in parallel or series or individually. It's pretty clever. It's nice to actually thought of those things to allow for tuning. That's those ones. You've got these 2 which you have to put in series to make the 800. So So I've got to go a bit closer to this end here instead, so I use this little jumper which is built into the board. One. And the other one. So these are actually Dale, which are decent resistors. Okay. Right, let's put some flux on this. I don't really want to use flux because it will make more mess, but I think it's just going to be best for the actual soldering quality. I try and avoid using flux if I can, to be honest, but sometimes it's just necessary to get the job done. So I'm using silver solder. If you want to ask, it's 6236. It says SN62 PB36 AG2. There we go. So 2% silver. That's the mix I'm using. I've got my iron set at 350 because I want to do this quickly. I don't want to put too much heat into the actual resistors. Unfortunately, there's a massive thermal plane here which is not easy to deal with. Let's see if I put enough dwell time on those to make them flow properly. I was trying to keep it as short as I could. They seem okay. So even though I put only a minimal amount of flux on there, it's all over the board. Because that's what I was trying to avoid. See how messy they got? And that's with very little flux added. But that's about how much I needed, I think. So that's all cleaned up. Probably good enough. Let's chuck it back in and see what happens. So, moment of truth. Let's see what we get. 100 shouldn't be affected. That's still okay. It's very slightly higher than 100. 200. It's now perfect. 300 is perfect. Pretty much, obviously, it's got a 100 slight rounding up there, which may or may not show up. 400 is perfect. 500 should be. 600 should be. So that's a 400 plus a 200. So it's reading very slightly down, that one. You'll see. 700 is good. 800 is good. 900 is good. Excellent. Obviously I need to do the same thing on the Siglent multimeter to show the high resolution, but this indicates it's not broken like it was before. So I've got it plugged into that module, and just that end module we worked on, and you can see you've got the 0 is indeed 0. So we'll do 100k. I've got 100 power line cycles set to try and reduce AC noise because it is a bit of a problem in this room, and we'll see what values we're actually getting here. Yeah, we may have to do some mental averaging. Yeah, that's alright. That's 30 high there. 20 high. Yeah, 38. So this one's reading very slightly high still. I do know that's reading high, so that's something I may need to look at. I may even get a whole bunch of 400s and like 4 of them and parallel them up or something. 200. So I'll give it a couple of update times. There we go. That's looking pretty good there. Happy with that. Allow for averaging as well, you know, mental averaging. You know, it's going up a little bit, down a little bit. I've also had less AC noise in this room. It's part of the problem I've got is this is electrically noisy room. You see the averages in the middle. It's where we want it to be. 300 should be a combination of both of those, so it shouldn't really matter too much. That will be slightly high because of the 100 being high, as expected. 400 is one of the other ones we did, which is the single resistor by itself without any compensation with parallel or series devices. So do mental averaging again, and you'll see that's sitting pretty close to the middle, I think. You just sort of see what the extremes are. So it's still very close. So if the mental averaging is around the 400 mark, very close to it, so I'm very happy with that. 500 is a combination, 600 is a combination, 700 is a combination of all three, so we'll see what that comes out like. So that's the 1, 2 and the 4 together. I expect that to be slightly high because of the 1 being high. And it does appear to be, again, mental averaging. So the low side's looking close, but it's actually not there. It's going to be slightly higher than that. So yeah, see, you can see the high end there. 800 is the other one we did, which is 2 in series. And again, a bit of mental averaging will be required. But I think if you average those out, like the extremes of what you're seeing, then you're going to be pretty close to what the actual middle is going to be, which is around 800. So it's like having there 60 down, 20 down, 45 up, 65 down, 30 down, 54 up, Yeah, 60 up. So it's probably about 10 down, I'd say, from where it's supposed to be. But I think that's good enough. So I've decided to go back and change this 100k because I wasn't happy with it. It's just too far value for my liking. So what I've done is I've been forced to basically bodge it in a way. I don't have any 100 or 200k resistors of precision value like that. Nothing good enough. So I've got a whole bunch of these 400s, as we know. So what I've actually done is I've basically put in 4 of those in parallel, which are, you know, obviously you had to piggyback 2 of them because of there being no PCB holes for them. So I've cleaned it up a little bit. I might have to do some more cleaning on it. It's not perfect yet. And in theory, this should be way closer than the original. So there's a 0. Let's try 100k. How close do I get it? Well, looks promising. Let me just change resolutions. So I'll change ranges to be the 200k range, so the 1 meg range. I like to use 1 meg because of the selection process. And obviously still got some RF noise and AC noise and stuff getting through, even though I've got the filtering and stuff on there. Now the previous one was 100.03, so we're significantly better. It's reading slightly high, but it's significantly better. You know, the mental averaging side of it, I'd say it's about 100.002, roughly. Yeah, there, about there. Not bad. So there we go. I think that's basically finished. I mean, I'm happy enough with that 100k resistor now. I would have liked to get it slightly better, but how far do you want to go with that? I mean, seriously. I'm still tempted to tweak it, but I'm probably going to just leave it alone. It's only a couple of ohms out effectively, so that's pretty good really. I think I might leave it alone. So make sure you check out my other videos, my repair videos. Subscribe and click like if you haven't already done that. Check out other repairs. If you'd like to buy things to repair. If you're also interested in supporting the channel, you can do Patreon. It helps to support the channel through that way. There's also a thanks link down there. If you like, below the video, there's like a thanks. Click on that. You can give me a one-off donation if you want to do that. Yeah, if you want to do that. Or you can just comment down below or give us a thumbs up, share the video. Those things all help support the channel as well. It's all helpful to me, so it helps to get the channel to grow further, which is always great. More growth, the better. Catch you later.